All right, so now let's see this particular question. So in this question, we are given a positive integer k, right? And an integer array which denotes the heights of different towers, right? What we need to do is we need to modify the height of each tower either by increasing or decreasing them by k only once, right? And after doing that, what we need to do is we need to find the um, minimum possible difference of the highest and the shortest towers after we have modified, the height of each tower, right? So basically what the question says is essentially we need to, for each of the element in this particular array, we only have two options. We can either increase a given element by k or we can decrease that particular element by k, right? But we cannot ignore it. We cannot skip any number. We only have two options for every number, either increase by k or decrease by k, right? That's what we have to do for every number over here. And we have to do it in such a way, like we have to select which numbers to increase by k and which numbers to decrease by k in such a way that the difference that I get between the highest and the shortest towers, or the highest number and the smallest number in my resultant array, should be minimized, right? That's what I need to do. I need to like select the numbers in such a way in which I will be increasing or decreasing, so that the difference between the highest and the shortest towers in the resultant array is minimized, right? That's the question, right? So now maybe you can just pause this video and try to think of a good solution for this. And once you're done, you can just come back and check the solution here. Okay, so now to solve this particular question, see what we can do is, first of all, the intuition is very simple, right? We need to decide till what point in this particular array we will be like increasing each element by k, like starting from the smallest numbers. We will have to decide till which number we will be increasing each number by k, and then after that number we will be decreasing each number by k. So we need to decide starting from the smallest number till which number we have to increase, right? And it might be the case that we have to like decrease all the elements. That can be a corner case, right? But then essentially this is what we need to do, that starting from the smallest number till which number I'm going to increase, right? And after that, I will be decreasing, right? So for doing that, what we can do is, first of all, we can sort the input array, right? Now, this particular example, if you see, the input array is already sorted, so we don't need to do anything. But then, I mean, it might be the case that the input array is not sorted, and in that case, we can just first sort the array so that, we have, all the elements arranged from the smallest to the largest, and now we can easily divide this particular array uh, with that particular condition, right? That till where we have to actually increase, and after that we will be decreasing, right? So that's why we will just sort this particular array. And now our objective is to basically divide this particular sorted array into two parts, right? And the first half, in the first half, every element we will be increasing by k, and in the second half, every element we will be decreasing by k, right? And what we will do is, for example, if I'm dividing first of all my array into two parts like this. First part only has 3 and the second part has all the other elements, right? So that means my division pointer, let me call it I, is right now pointing at 3, right? And these are all the elements which I need to decrease, and this element is what I need to increase, right? So what I will do is I will add 3 to this particular number, it will become 6, and then I will deduct 3 from all these numbers, right? And now what I need to do is I need to find if this is my division, right? If this is my division point, then sitting at I, what will be the minimum difference between the shortest and the highest tower in the resultant array after I have added and subtracted k from each of the elements respectively, right? So if you see over here, the minimum element can be either, this one, right? The first element where I'm like standing, the first element of the array, that could be the minimum element, or the minimum element could be this one, right? I plus 1 plus k minus k, right? So it could be either, array of 0 plus k, right? Or it could be array of I plus 1 minus k, right? Those two are the possibilities for my minimum element, right? So let me just write it over here. So my minimum element could be one among either, array of 0 plus k, right? After I have added k to 0, it could be that, or it could be array of I plus 1, that is the next element after my current division pointer, minus k, right? I mean, because it could have become the minimum element after I reduced k from it, right? So that is the only possibility, right, for the minimum element. And for my maximum element, the maximum element could be either the last one minus k, right? Or it could be the, I mean, this particular element itself, that is the ith element plus k, right? So it could be either array of I plus k, right? Or it could be array of n minus 1 minus k, right? These could be my maximum elements. So I will just take maximum of these two, right? And I will take minimum of these two, right? And then I will take a difference between the maximum and minimum, and that will be my current difference between the highest and the shortest towers from the resultant array if my division point is this 3 itself, right? Now, this is what I will do over here. Now, after I have calculated this particular value for the current division pointer, then I will move the division pointer, that is my I pointer, to the next element, right? Now what I'm saying is I'm dividing the array into two parts such that you know these two numbers essentially are the ones which are a part of the first part of the first half of the array, and the rest of them are in the second half. That is, I will be increasing these two numbers by k and reducing all these numbers by k, right? So now what will be my minimum and maximum element? So it will be again following the same rule, minimum of either array of 0 plus k, or it could be array of I plus 1 minus k. That could be my minimum element. So if you see over here, this will be 6 after I add 3 over here, and I plus 1 will be this, minus k would be 9, right? So again, my minimum element is still this only, right? That is 3, correct? And then when I talk about the maximum element, it could be either array of I plus k, that is, the maximum element of this particular division plus k, so that would be 12, right? Or it could be array of n minus 1, that is the last element of the array, which is anyways the maximum, minus k, right? So that would be 20 minus 3, 17. So obviously this is my maximum element. So I will just do this 17 minus 6, right? Because 6 was my minimum element, right? So that's what I will get, and that value I will just compare with the last difference that I got for the last iteration, right? So what I will do is I will just keep doing this at every point. I will just keep shifting my I pointer to the right, and at every point, in every iteration, I will just keep calculating my current min by using this particular formula of maximum and minimum. This is how I will find maximum and minimum at every iteration, and then I will just keep finding the difference, and I will keep comparing it with the minimum difference that I have seen so far, right? And then if the current minimum that I'm seeing at this particular point is actually lesser than the overall minimum that I've seen so far, I will just make that as my overall minimum, the minimum difference. And at the end of the entire traversal, when I have exhausted all the elements, then whatever is the value of my minimum difference, that's what I will just return as the output of the function. That will be my final answer. That will be the minimum difference possible between the highest and the shortest towers after I do this operation on this particular array, right? So that's the strategy that we are going to follow. I hope you understood it well. The entire idea over here is to divide this particular array. First of all, of course, sort it. Only then we can divide. But essentially, we need to divide this particular array in two halves such that the first half, all the elements we will be increasing. And in the second half, all the elements we will be decreasing, right? We just need to find the optimal pivot for doing that division, optimal point to do that particular division. And that optimal, the definition will be described by this particular condition, that the difference between the the maximum number and the minimum number should be minimized, right? So that's why at every division point we are checking what is the difference between the maximum and the minimum, right? And whichever point we get the minimum difference, that's what we will return, right? So I hope you understood it well now. Now maybe let's jump to the IDE and code this particular solution. But before that, let's also talk about the time and the space complexity. Now, if you see over here, we are not using any extra space over here. So the space complexity will be order of 1. And talking about the time complexity, we are just traversing this particular array once, right? And at every point, we are doing these two operations. We are finding the minimum and the maximum. So those are constant time operations again at every point that we are doing. So essentially the entire time complexity will be linear. We are just traversing this particular array once, and so it will be order of n, right? So time complexity will be order of n and space complexity will be order of 1, right? So now let's jump to the IDE.
All right, so now let's code the solution that we just discussed, right? To start with, what I will do is I will just declare a function. I will just name it as get mindiff, right? And this will accept two parameters. One will be k, right? And another will be the input array, right? And now what I can do is I can just capture the length of this particular array in a variable n, right? And now what I can do is I can just sort this particular input array, right? And since I'm using array.sort over here, this is a Python method which will sort the array in place, right? And then I will just declare my minimum difference variable, right? And this minimum difference variable will be the one which I will use to track the minimum difference that I've seen so far at any point in time, right? At every element when I'm actually iterating over the entire array, at every element, this particular variable will hold the minimum difference that I've seen so far till that particular element, right? And if at any element I get to have my current minimum lesser than this particular minimum difference that I have at that particular point in time, I will just reassign my current minimum to this particular variable, right? So that's what I'm going to do. That's how I'm going to use this particular variable. And to start with, I will just initialize it with the current difference that I have between the maximum and the minimum element of the original array, right? So that's what I will do to initialize it, right? This would be this array of n minus 1 minus array of 0, right? And if at all I'm retaining this particular value at the end of the entire iteration of the array, it would mean that this is actually my minimum difference between the maximum and the minimum height, the original one, right? But now you would be wondering that the question says that I absolutely have to make change to every element. I cannot skip any element. Then how can I retain this value? Then to retain this particular value, what I can do is I can either increase all the elements by k, right? And or I can reduce all the elements by k, right? Because see, if I am reducing all the elements or I am increasing all the elements by the same amount, their difference is going to stay the same, right? So that's why if I am able to like maintain this initial value of the minimum difference till the end, right, it would mean that I can actually get this particular difference by either increasing all the elements by k or by reducing all the elements by k, right? Either ways I will be getting this minimum difference only, right? So that's why I will just use this particular value as the initial value of minimum difference. And now what I can do is I can just run a for loop over my input array like this, right? And I will go only till the second last element, right? And I will tell you in a while why. So because we are going to like refer the next element sitting on the current element every time, and that's why we have to only go till the second last element. If I go till the last element and try to refer the last, like the next element, there would be no next element and I will get an index out of the range error, right? So that's why we will be going till the second last element. And now what I need to do is I need to find the current minimum at this particular position, right? So what I'm saying is that if at all I'm making that division, right, the division that we were discussing, that in the first half we will be increasing all the elements by k and in the second half we will be reducing all the elements by k. So if this one, I assume, like if this I is the point where I'm assuming is going to be my division point, then the current minimum, the minimum difference that I can get by choosing this one as the division point would be the maximum value, right? The maximum number that I can have by choosing this particular element as the division point minus the minimum number that I have, right? And the maximum value could be either array of I plus k, right? Or it could be the last element, which was the maximum number in the original array, minus k, right? This is the same thing that we had discussed earlier, right? And then my minimum element could be either array of 0, which is my first element, plus k, right? Or it could be the first element of my second half, right? Which will be array of I plus 1 minus k, right? So these are the two candidates for my minimum element, right? and these are the two candidates for my maximum element if at all I'm choosing I as my division point, right? So that's my current minimum, and now what I will do is I will just compare it with the minimum difference that I have seen so far by taking the minimum between the minimum difference and the current minimum that I just calculated, like this, right? And whichever is the minimum will get reassigned to minimum difference variable, right? And after I have iterated all the elements of this particular array, right, I will just return the minimum difference, right, like this. And if at all, again, like just trying to reiterate, if at all I'm unable to find any minimum at any element which is lesser than the current, like the initial value of the minimum difference, it would mean that, you know, I can actually get this particular minimum difference by either increasing all the elements by k or reducing all the elements by k, right? But that is immaterial in this particular question. We are not supposed to return that in the output, that, you know, which all elements we are increasing and which all elements we are decreasing. We just have to return the minimum difference. But I'm just trying to explain you that in which scenario this minimum difference will hold true, right? So that's the entire solution to this particular problem. I hope you liked this. I hope you understood it well. And now I will see you in the next question. Thank you.